Hello everyone, this is Nihal and let us solve the question 4C of paper 2 of mathematics optional UPSC Civil Service Examination 2022. It says that use the Vogel's approximation method to calculate the initial basic feasible solution of this given transportation problem and also use the initial basic feasible solution to obtain the optimal solution of the given transportation cost problem. So let us solve this. So this is the given problem, and Vogel's approximation method use penalties as a tool to allocate to determine the basic cells and allocate the demand and supply to to these cells. So let us calculate the penalty for the first column, penalty for the rows penalty. So what is penalty? Penalty is a difference between the minimum cost in the row and next minimum cost of the row. So minimum cost is 13 and next minimum is 16. So penalty is the difference is 0.3. So penalty is 3. So for the second row, penalty is a difference between 14 and 18, that is 4. So in the third row, difference between the minimum cost and next minimum cost is 9. So penalty is 0.9 for the third row. Similarly, penalty for the column. For the first column, penalty is 0.4. For the second column, penalty is 0.2. For the third column, penalty is 4. And for the fourth column, penalty is 10. So what we do is we allocate maximum possible to that cell which has uh, minimum cost in the column or row of the maximum penalty. For example, 10 is the maximum penalty, so this we choose this fourth column and we allocate to the cost to the cell of minimum cost per unit. So 13 is the cell which has minimum cost per unit, so we allocate a maximum possible units to this cell. So here availability is 11 and demand is 15, so maximum possible allocation can be made is 11 to this cell. So now the availability in the first row is exhausted, so we write cross in all these cells of first row. Now we can recalculate the penalties for the remaining cells or remaining rows and columns. So penalty for the columns, here penalty is 15. For the second column penalty is 9. For the third it is 4, and for fourth it is 18. For the rows, for the second row penalty is 3. For the third row penalty is 9. Sorry, it was 3 for the first time also. So here highest penalty is 18. So we choose the fourth column, and in fourth column minimum cost per unit is 23. So we allocate to this cell 2 4, whatever the maximum possible units. So here demand is remaining demand is 4 and availability is 13, so we allocate 4 to the cell 2 4. Now we can write cross to this cell because all the demand is exhausted in the fourth column. Now we recalculate penalties for the columns. Penalty for the columns it is 15, it is 9. For the third column it is 4. For the rows it is 3 and 9. So highest penalty is 15 for the first column. So and minimum in the first column minimum cost per unit is 17. So we allocate maximum possible units to this cell. So it is demand is 6 and availability is 9. So we allocate 6 to this cell and write cross in the cell 1 3 1 because all the demand of first column is exhausted and availability for the second row is 0 3 now because 4 and 6 is already allocated. So for the remaining rows and column, we calculate the penalty. Penalty for these two rows and two columns is 9 and 4, and penalty is 4 and 9. So now it is a tie between 9. So we will allocate to that cell which has minimum cost. So in both the cases, minimum cost per unit is 18. So we allocate in this cell 2203. Now we can write cross here. Now we don't have choice, but we allocate whatever remaining availability and whatever demanded. So here we allocate 07, and in this cell we allocate 12. So by Vogel's approximation, this is the initial basic feasible solution, that is x14 is equal to 11, x21 is equal to 6, x22 is equal to 3, x24 is equal to 4, x32 is equal to 7, and x33 is equal to 12. So this is initial feasible solution. Now we need to check this is basic feasible solution or not. For that we need to have m plus n minus 1 allocations. Here m and n are number of rows and columns. So there are 4 columns and 3 rows minus 1 is equal to 6. There need to be 6 allocation in the initial solution. So we have 1 2 3 4 5 6 allocations. So that means it is initial basic feasible solution. So feasible solution. So what is the total cost of initial basic feasible solution? Total cost is equal to summation Cij Xij, where Cij is the cost per unit of the basic cell and Xij is the allocated units. So it is equal to 17 into 6 plus 18 into 3 plus 23 into 4 plus 11 into 13 and plus 7 into 27 plus 12 into 18, which is equal to 796. So this is the total cost of initial basic feasible solution. Now we will use UV method to optimize the obtained initial basic feasible solution. UV method to optimize. So okay. So this is initial basic feasible solution. We use UV method. What are these U and V's? These are dual variables. Dual variables associated with rows are U1, U2, and U3. V1, V2, V3, and V4. How we calculate these dual variables? We define delta Ij is equal to Ui plus Vj minus Cij. For the basic cells means cells which have allocations in the initial solution. For example, this cell is basic cell, this cell is basic cell, this cell is basic cell. These are six basic cells. For these, delta I has to be 0. So for example, U1 plus V4 minus C14 is equal to 0. So we will get the, 6 equations, and UI and we say we have 7 variables. So we have one more variable than the equations. So we randomly choose a variable and allocate it 0 value, and then we have 6 variable and six equations remaining, then we will solve the remaining equations. So let us allocate u2 as 0 value. Why we have chosen u2 is because column row associated with the u2 is this second row. This has maximum basic cells, so it is easy to calculate other ui vj if we allocate 0 to assign 0 value to that dual variable which has a maximum basic cells associated with it. So we assign 0 value to u2. Now u2 plus v4 is equal to 23, so v4 is equal to 23. Similarly v2 is equal to 18. Similarly v1 is equal to 17. Now we have V2 plus U3 is equal to 27. We have V2 as 18 plus U3 is equal to 27. So U3 is equal to 9. Similarly, we have V4 plus U1 is equal to 13. V4 is we get 23 plus U1 is equal to 13. So U1 is equal to minus 10, is equal to minus 10. Now what we do is net evaluation. Net evaluation for those cells which are not basic, that means which do not have allocations any unit. So for that we evaluate delta ij. So let us calculate delta ij for the remaining cells. So delta 1 1 is equal to u1 plus v1 minus c11, which is equal to 17 minus 10 minus 21, which is equal to minus 14. So this is minus 14. For this cell 1 2 is equal to 18 minus 10 minus 16, which is equal to minus 8. For cell third cell 1 3 is equal to, so we haven't calculated yet this v3 is equal to 0 9. So 9 minus 10 minus 25, which is equal to minus 26. So this is minus 8, this is minus 26. For the cell 2 3 is equal to 9 minus 14, which is equal to minus 5. This is minus 5. For delta 3 1 is equal to 17 plus 9 minus 32, which is equal to minus 6. This is minus 6. And delta 3 4 is equal to 23 plus 9 minus 41 is equal to minus 9. This is minus 9. All the net evaluation are negative. That means by UV method we get optimal solution. This is optimal solution. So it remains the same as nothing has been changed after initial basic feasible solution. So it remains same as total cost, total minimum cost is equal to 796, and this is optimal solution because all the net evaluation for the non-basic cells are negative. So that means it is optimal solution, and cost and the allocations to the cells are x11 is equal to x14 is equal to 11, x24 is equal to 4, x 1 x21 is equal to 6, x22 is equal to 3, and x32 is equal to 7, and x33 is equal to 12. So this is a optimal solution which is minimum. Thank you guys. You can join Telegram group. There you can ask your doubts. Thank you guys. So we have completed the A part of the paper 2 of UPSC Mathematics Optional 2022. So and the other solution also will be provided soon. You can join Telegram.